Today's lesson is on solving problems using the equation P1V1 over n1T1 equals P2V2 over n2T2. And these are all problems involving gases. And that's pressure and volume, and N is moles and T is temperature, like we talked about in class. So I pulled this example from your problem book. It's on problem book 712, problem 7F. So pause the video and get the problem book out so you can put this down right while I'm doing this, and you can save it as an example for your other problems. So this is what it reads. There are 40 liters of a gas, and this gas is under pressure at 120 atmospheres at 25 degrees Celsius. What volume will the gas occupy at 1 atmospheres and 0 degrees Celsius? So before we solve this problem, I'm going to remind you of some hints we talked about in class. One is to take that equation that we had at the beginning, the P1V1 over n1T1, and cross out any variable that is held constant. And assume if it wasn't mentioned in the problem, it is held constant. And then hint number 2 is you have to use the same pressure volume units for both sides. So if you're on atmospheres on one side, you're on atmospheres on the other side. If you're in millimeters of mercury, you have to be millimeters of mercury for both sides, milliliters or milliliters. If they give you different pressure 1 is in atmospheres and they give you pressure 2 in millimeters of mercury, you will have to convert it. Either both to millimeters of mercury or both to atmospheres. And then the last hint is use only Kelvin. So let's go back and start that with this problem. And so I have the P1V1 over n1T1 equals P2V2 over n2T2. And if I read this problem carefully, I notice I'm given a pressure. So this is a pressure reading. I'm given a volume. This is a volume reading. I'm given a temperature. This is a temperature reading, but I'm not given anything about moles. So you can cross it out, or if you have done this in pencil, or I can do this on my screen because I'm going to use this eraser, and you can just get rid of the N. So I now have P1V1 over T1 equals P2V2 over T2. So now I also cover, so I did 1. Pressure units have to be the same. So let's go back. Pressure, I have atmospheres and atmospheres. They're the same. Temperature, I have both in Celsius, and volume, I only have 1 volume. So my answer is going to be in liters. So I've done that. And then 3, I said Celsius and Celsius. I should have noticed right when I said that, only use Kelvin. Remember, all of these problems for all of this unit needs to be in Kelvin because it's the only scale where 0 actually means 0 for temperature. So I have to go back and switch to Kelvin. Kelvin's really easy. You get Kelvin by just adding 273.15. So if I take 25 degrees Celsius and add 273.15 to it, oops, that's the bell. We're still going on. Or if I add 0 degrees plus 273.15, I get on the top 298.15, or you can round it, but usually we say rounding to the end, and this is in Kelvin. So I remember that it really should have been rounded right here in the tenths place, but we can round at the very end, or you can round now. It's better to round at the end, and I get 273.15 Kelvin here. All right, so let's go back to our hints. I crossed out the variable that wasn't mentioned, which is moles. The units are the same on both sides, and I only use Kelvin. All right, so am I done? Did I solve the problem? No. The problem really was, what is the volume? I still haven't solved for the volume. So I have to continue working on this problem. So I also have some more steps. So take a pause and write these down somewhere. Pause the video. I'll still be right here, and write these steps on a piece of paper. 1, write the equation, which we already did because it was a part of our hints. So we had P1V1 over T1 equals P2V2 over T2. Then I'm going to substitute in my values. Instead of saying P1, I'm going to put the pressure. Instead of saying V1, I'm going to put the volume. So I'm going to substitute in the values with the units. Then I need to isolate the unknown variable. That's like in math when you get the x on one side of the equation and the numbers on the other side. So I'm going to solve this time for v. So I'm going to get v by itself. I'm going to mathematically get out my calculator and do the math and solve for it. And then I'm going to check my answer. So write the equation. So I had P1V1 over T1 equals P2V2 over T2. Then I'm going to substitute the values. So the initial pressure, if you're reading the problem with us on 712, was 120 point atmospheres. That tells me there's 3 significant figures. The volume was 40.0 liters. The temperature, which we now have changed into Kelvin, is 298.15 Kelvin. The final pressure was 1 atmosphere. And notice the units are the same, atmospheres on both sides. The final volume we don't know. That's our unknown. That's our variable. So that's V for volume, V2. And the final temperature we changed to Kelvin was 273.15 Kelvin. So now I'm going to solve for V2. So you can do this many different ways. I like to cross multiply. So that would be multiplying these and then multiplying by these. So then I would have 120 times 40 times 273.15 equals 298.15 times 1 atmosphere times V2. And I ran out of room, so I put it on the bottom. So I'm still not done. I haven't isolated V2. So then I have V2. I multiply all of this side, and now I've got to divide it by this. So really I only have to divide by 298.15 because dividing by 1 doesn't get me anywhere. So 120, so I plug into my calculator, 120 times 40 times 273.15 divided by 298.15 gets me this for a volume, 4,397.5 liters. And hopefully that sounds wrong to you because, wow, that's way too many significant figures. So I had 3 significant figures here, 3 here, 3 here, 5 here. And remember, this was really rounded here, so 4 there. So I can only have 3 significant figures, which is a little bit of a problem. So I've got to stop here, but I have to round that up, which rounds this up. So I end up with 4,400 liters. But that looks like 2 significant figures. So what am I going to do? You could write 3 sig figs in parentheses. Okay. Or I could change this to kiloliters, which is 4.40 kiloliters, or do something so I know that there are 3 significant figures. So I did the equation. Oh, another bell, but we're still going on. So I did the equation, I did the substitution, I isolated the variable, and I solved it with sig figs and units. And now I should check the work. Did I expect to have a big volume? 440 liters is pretty big. So did I do anything drastically? So I changed it to very large amount of liters? Yes. Notice the pressure change from 120 to 1. That's a big pressure change. So as pressure went down, volume went up. And since it was a big pressure change, I would expect a big volume change. So now I did a gut check, and yes, I do like that answer. And there we have it. So now go and try some yourself. Thanks for listening.